Okay, so Elementum 3D. We develop new materials for additive manufacturing, primary in the metals additive manufacturing space. We work in metals and ceramic composites and develop new products and materials based off of that. Next slide, please. So the current problem with a lot of additive manufacturing is you're limited to the materials that you can choose because it is typically a welding process. And a lot of those materials you can't produce, they have poor properties, and you can't make the same component that you could say with CNC machining. Next slide, please. Our materials and the development of our materials allow the use of all sorts of materials, whether those are traditional materials or new materials like metal matrix composites, high-tech materials that we couldn't produce using CNC that are now possible because we have all of the design freedom and now the materials freedom, which isn't typically thought of in additive, that didn't exist before. So we can do things and design things with materials that were not possible to make previously. Next slide, please. So we've been in business for about 6.5 years now. We've developed a number of different materials for all sorts of applications, whether that's rocket engines, in which we have a small manufacturing setup to help transition and develop new rockets for space flight. Then we have a number of different technologies and developments that we've been working on for all sorts of other fields as well, whether that's lightweighting for aerospace design. Typically it's consolidation of parts for all sorts of applications, whether that's just for lightweighting or actually more popularly for reducing the supply chain and improving the security of that supply chain as well. So there's a number of different fields that we've been focusing on, both in space, aerospace, high-end automotive manufacturing, cooling for, say, data farms and servers. And then recently, there's been quite a bit of interest in hydrogen extraction for fueling as well. So a number of different fields where we can apply all sorts of materials from high-strength aluminums, ultra-high temperature nickel superalloys. Recently, NASA contracted us to produce and develop their systems and settings for GRCOP 42 and a few other materials as well. Next slide, please. So our business model is that we develop materials and we sell those materials to people who own these metal 3D printers. We develop the settings and the post-processing for those printers to be used with our materials. So OEMs like Lockheed Martin, Moog, those sorts of companies could purchase our materials and print their components using those high strength materials. From there, we also do consulting services and help those companies take it from that initial concept to an actual producible part that can compete and even in most cases beat that component by 60–70% performance improvements, which we found you have to be at that 60–70% improvement for someone to adopt this new type of manufacturing technology. And further than that, we do a lot of initial run manufacturing as well. So we'll help develop different products and develop the manufacturing line on our end, and then transfer that to the end use customer so that we can transfer our knowledge and help that customer set up the manufacturing. Next slide, please. So a number of our customers that we can talk about, most of our customers we can't talk about and we can't say their names, which makes that very difficult sell. But some of the customers that we have done business with and have posted publicly as what they're doing, it might be Ball Aerospace, Maston Space Systems, we've done quite a bit of work with, and then a number of the DoD contractors that are directly contracting with the Army, with the Air Force, and with the Navy, we've done quite a bit with as well. We've also been awarded about $5 million in contracts with NASA, the Air Force, and others over the past 5 years. Most recently, we were awarded a phase 1 SBIR with the Air Force to develop and further develop high stiffness aluminum materials for replacing all sorts of maybe caustic or materials like beryllium containing alloys, which can be really dangerous to people's health. So we've been working on those sorts of materials recently.
3-second warning.
Next slide, please. So our technology is really based around the development of those new materials, and our IP, which is based around what we call reactive additive manufacturing. And essentially, we're forming these materials and adjusting their microstructures based off of adding these reactive components to it, which are actually forming and reacting during the printing process in a very controlled way, so that we can develop and change the microstructure and strength and properties of those materials as we go. Next slide, please. Um, and there's different advantages to that, and there's highlights here, but I think the biggest highlight on this slide is that we can print materials that you can't print otherwise. So by using this technology, we can print high strength aluminums, which traditionally you could not do, and others have not been able to figure out how to do. Next slide, please. We're looking to do a Series B raise. We've raised up to $10 million so far, and we're looking for a Series B coming up this summer to do an additional $20 million raise. And we're looking at very, very large revenue improvements. We're already profitable as of this year, which is exciting. We've tripled our revenue recently. So there's quite a bit of work being done there, including relatively large contracts that we slot in well as a subcontractor on. So that's the sort of work, and that's what we're looking for from this sort of relationship. So next slide, please. And that's our team. So I don't think I have to go too far into that, but we do have a significant team of metallurgists on staff and people who know the other side of it as far as sales and accounting.
Thank you, Jacob. Open up the floor to questions for Jacob in Elementum 3D.
Hey, Jacob, this is Dana again. We've started to get the sense that metal additive manufacturing powders could be a potential bottleneck in the supply chain for advanced air mobility, right? For eVTOL vehicles as they come up and scale. Is your solution? I mean, if I'm a startup in AAM and I just invested a whole bunch of money in Velo 3D equipment or whatever, are you saying we can just basically drop your powders in and it won't take any tweaking in terms of the power sources or anything else with the existing commercial off-the-shelf equipment?
That's correct. The commercial off-the-shelf equipment is usable. As specifically with Velo, we haven't developed our settings for the Velo equipment in particular, but choose about any of the other ones we have. Velo is just a younger company. It would take us about 6 months, and we could work directly with Benny from Velo, who we've met a number of times and talked about projects. So absolutely, that's something where we are taking our materials and dropping them directly into the printers out there. EOS is the most common and most familiar. I think it's about 60% of the metals market. We have a good relationship with them. Also with SLM 3D Systems, we're about 20 miles from. So yeah.
Are you reliant on imports for any of the specialized chemicals involved with this, or is it stuff that you can source pretty easily?
Specifically, we're sourcing it in the US because a lot of our customers require that.
Yeah. Okay, thank you.
Hey, Jacob, you mentioned Moog in your pitch. I'm not an additive guy, but I know we do a lot of stuff. Are you engaged with Moog right now? If you're not, I can make a connection for you.
I don't need the connection. And
okay.
I don't know how much I can say.
That's fine. It's in my group. I just, yeah, that's fine. Yeah. No worries. But I was just going to help you out if you needed it.
Guys pretty well. We know those guys pretty well.
Jacob, are you doing anything with housing at all, with 3D printing of housing?
So we're not. We're focused mainly on the metals market, which doesn't go into, say, like concrete printing as much. But
well, I meant for multi-story buildings, even commercial buildings, as far as if you can print out the infrastructure and redesign the way buildings are built, and they can go up a lot faster with just similar to an early presenter, without the dangerous heights and things that humans have to do skyscrapers and stuff. I should have said commercial. Yeah.
We are spinning out actually a wire division that will be going into wire feed additive manufacturing for doing things like building more structural components for larger pieces. So that is something that we're just starting into, and we're looking actually at an SBIR with the with NASA, looking at some structures there, but we haven't gotten into printing and construction yet.
Okay, thanks.
Okay, that was Elementum 3D. Any other questions? Feel free to connect to Jacob after.